Hey, hello, my name is Daniel, and I will quickly introduce my poster that's entitled Continuous Variable Feed-Forward-Powered Topological Photonics. Okay, so essentially, this poster is about a proposed system that will use telecommunications technology, such as heterodyne detection, C-band coherent light, modulators, etc., to do some interesting physics, namely experimentally realize some condensed matter phenomena. Okay. So what I do is I initially introduce what topological photonics is and why it's interesting, as I assume most people will not have heard of it. Um, and I then introduce a sort of simple topological model that can be used to explain the physics of a type of topological material called a topological insulator. Okay, and essentially what we want the system to do is to emulate this model called the Shu-Schriever-Heeger model that acts essentially as a proof of principle that our system will work. Okay, so the hallmark of topological insulators is that they host what are called edge states. Okay, and these are states that are robust against disorder and imperfections. So if you can imagine a optical device hosting these states, it would essentially mean that the light can move through the material without loss, even in the presence of imperfections of the device. Okay, um, so on the right hand side, then I just introduced the system, which essentially is a fiber loop that hosts 24 pulses that get measured and then operated on by a FPGA. I introduced the FPGA architecture and explain how we sort of emulate the physics of the SSH model and this optical setup. And then at the end, I give just some brief, just some simulation results of the system to show that we expect that it should work as proposed.